Hi guys, this is Unit 4, Lesson 4, Piecewise Linear Functions in Context. This is just a whole bunch of word problems again. So piecewise linear functions look like this. It's been a while since we've touched on these. They're used to display information in a reader-friendly way. They can be graphed and formed through the use of points and equations. The equations can include slope-intercept form, standard form, or point-slope form. They're all linear equations in this lesson. Writing piecewise linear functions. On her way to the library, Michelle stops to buy gas for $3.75 a gallon. If a customer buys more than 8 gallons of gas, the price is only $3 a gallon for the gallons beyond 8 gallons. This is something they keep going back to in these problems. I have never seen a gas station that lowers the price when you buy more gallons, ever. I don't think this is a real thing. Michelle's tank holds 12 gallons. Write a piecewise function to represent the scenario. So here's the steps to writing a piecewise linear function. First, define the situations presented in the word problem and the bounds that will represent the domain of the situation. So this is using inequalities to represent, like, okay, this piece goes from here to here, this piece goes from here to here. Second, form the first piecewise function and points to represent the situation. Third, form the additional piecewise functions. Fourth, use brackets to write the final piecewise function. And fifth, graph each situation. So if the steps are helpful to you, write this down and put it in your notes. Sorry, example number 1. On her way to the library, I'm going to keep coughing apparently. Michelle stops to buy gas for $3.75 a gallon. If a customer buys more than 8 gallons of gas, the price is only $3 a gallon for the gallons beyond 8 gallons. Michelle's tank holds 12 gallons. Write a piecewise function to represent the scenario. So step 1, define the situation. The first part of the description represents $3.75 a gallon up to 8 gallons. So the smallest amount of gas is 0 and the maximum is 8. Therefore, the domain for this situation is x is greater than or equal to 0 and less than or equal to 8. If you buy any amount of gas within those bounds, you're going to pay $3.75 a gallon. The second description represents $3 a gallon for 8 to 12 gallons. The smallest amount of gas is 8.01 gallons and the maximum is 12. Therefore, the domain for this situation is x is greater than 8. It's not equal to 8 because equal to 8 is in the last domain. So it's x is greater than 8 or less than or equal to 12. So step 2 is to form the first piecewise linear function using the first part of the description. So first you need to create the function. The gas is priced at a constant rate. Therefore, this can be modeled as f of x equals 3.75x, where x represents the number of gallons and f of x is the total price. So there's your formula. We're going to create ordered pairs based on selected x inputs that represent the start, middle, and end of the function. So what that means is we're going to have x inputs that are the lowest value you can have, which is 0. The highest value is 8, and the middle, which is 4, because 8 divided by 2 is 4. Then we're going to take our formula that we just created, and we're going to plug these x values in to find our y coordinates so that we can plot this on a graph. So we're going to go f of x is equal to 3.75 times x, which our first value of x is 0. 3.75 times 0 is just 0. So our first coordinate pair is 0, 0. That's going to be our starting point. Okay. Our next one is f of x is equal to 3.75 times our next x value, which happens to be 4. And boy, howdy, you better believe I'm getting the calculator out for that because I'm not playing that game. I am way too tired for that. 3.75 times 4 is 15. So our y coordinate for that one is 15. And our last one is f of x is equal to 3.75. This is the formula from right over here. Times 8. And we're getting the calculator out for that one too. So 3.75 times 8 is 30. So that gives us 3 points for just the first part of the graph that says, up to 8 gallons of gas, it's $3.75. Okay. So there's our coordinates. Step 3, Form the next piecewise linear function using the second part of the description. So we're dealing with the second part where the price per gallon goes down to $3 a gallon between 8 and 12 gallons. Create the function from where you stopped in the first equation using point slope formula y equals y1, y minus y1 equals m times x minus x1. So y1 and x1 are where we stopped, these two values, in our last problem, okay? The gas is priced at a constant rate, therefore the slope of the new function is 3, okay? We get that from this problem up here. The previous function stopped at 830, therefore this is where you want to continue the next function. So what we're trying to do is plug in the information we have into this formula and get our y equals mx plus b type formula, okay? Plus b, right? So we don't know what y is yet. Equals y1 is, minus y1, which is 30, equals m, which we know is 3, times x, which we don't know, minus x1, which is 8. All right? So the first thing we need to do is PEMDAS rules. We need to distribute this out. So 3 times x is 3x, and 3 times negative 8 is negative 24. So now we have y minus 30 equals 3x minus 24. We still have this 30 over here that shouldn't be here, so we're going to add 30 to both sides. Okay. I'm running out of room, so I'm going to move down to the bottom. So that's going to leave us with y equals 3x, 30 minus 24 is 6. Okay, so this is our new formula, and you can see it right here. Step 4, use brackets to write the final piecewise function. Okay, so we always start with f of x is equal to, and then the bracket shows that all of this together is the correct answer. The function that represents the scenario 1 is y equals 3.75x. That's our first formula. Remember, f of x and y are interchangeable, so we don't need to do anything else. That's our first formula. With a domain of 0, 8, and that's written as x is greater than or equal to 0 and less than or equal to 8, because both of these points are included in that domain, okay? Scenario 2 can be represented by the function, this one right here, f of x or y is equal to 3x plus 6, so there's our formula, and the domain is 8, 12. So x is greater than 8, because 8 was already included here, so it's not greater than or equal to. It can only be 8 one place. So greater than 8 and less than or equal to 12. Okay, we'll keep doing this. If it's not quite clicking, it's okay, you'll get there. Check in. What pieces of information are needed to plot piecewise linear functions? The linear function and the domain of each function. So you need the actual problem and you need the domain, okay? Now I'm telling you this now because you're going to see how quickly this derails. My theme for this was skunks, because I think skunks are super cute. Example 2, an employee at a grocery store earns $15 an hour. He earns $20 for each hour over 40 that he works. That's really crappy for overtime wages, just so you know. It's usually like time and a half. That's like $5 extra an hour. That's lame. Create a piecewise function and graph to compare his earnings versus the number of hours worked up to 60 hours. So step 1, define the situation. The first part of the description represents earning $15 an hour up to 40 hours. The lowest number of hours that can be worked is 0, and the highest is 40. Therefore, the domain for the situation is x is greater than or equal to 0 and less than or equal to 40. Okay. The second part of the description represents earning $20 an hour for each hour over 40. The lowest number of hours that can be worked is 41, because we're dealing with whole hours here. They don't pay for partial hours because employers are cheap, okay? So 41's the lowest, and the highest is 60, because you can't work more than 60 hours a week, I guess. I don't know. Therefore, the domain of this situation is x is greater than 40, because 40 is not included, and less than or equal to 60, because you can work 60 hours. Step 2, form the first piecewise linear function using the first part of the description. So we're going to write the formula, create the function. The employee works at a constant rate, therefore this can be modeled as f of x equals 15x, where x represents the hours and f of x represents the amount earned. 15 is the slope or the rate of change. Okay. Then you're going to create ordered pairs based on selected x inputs that represent the start. He starts at 0 hours. The middle is 20 and the end is 40, because the most hours he can work in this first section is 40. 40 divided by 2 is 20. So again, we're going to take our formula. You're just going to plug in your x values. We'll go with the middle one as an example. Write your formula, plug in your x value, which in this case happens to be 20. I'm totally busting out the calculator for that because I'm not smart. I'm not. 15 times 20 is 300. So this point is going to be 300. You would do that for each point on this table, same process, okay? And it gives you this. Now, form the next piecewise linear function using the second part of the description. Create the function from where you stopped, which is 4060, okay? 4600, is that right? Yeah, okay, 4600, sorry. Using point slope formula. So we did this before, okay? The job is paying a constant rate of $20 per hour. We're on the second section. So this is our M, this is our slope. After reaching 40 hours, therefore the slope is 20. The first function stopping point is at 4060, okay? So we have y minus y1, which is 600, okay, equals M, which is 20 times x minus x1, which is 40. So we're going to distribute with our multiplication in parentheses first. So we have y minus 600 equals 20x minus 800. Okay. Now we got to get rid of this 600, so we're going to add 600 to each side. Okay, which is going to leave us with y is equal to 20x, sorry, this is 600 minus 200. There is our new formula. Okay. Now create ordered pairs based on selected x inputs that represent the start, middle, and end of the function. We know we're starting at 40, we're ending at 60, and in between them, the middle point between those two is 50. Okay. Let's take this formula, plug in your x value. We'll do our top one this time. We have y equals 20 times 60 minus 200. 20 times 60 is 1200 minus 200 gives us the point 1000. You would do that for each of the 3 points. Okay. So step 4, use brackets to write the final piecewise function. We have f of x equals and an opening bracket. Then within that opening bracket, we have our first formula, which is 15x. And then we have our domain. X is greater than or equal to 0 and less than or equal to 40. We have our second formula, which is 20x minus 200. And our second domain, which is x, is greater than 40, because it could only be one of these places, not both, and less than or equal to 60. It should be clicking and making a little bit more sense now, okay? This is what the graph looks like. You just plot these points, okay? And you can see what it looks like. I'll blow this up a little bit bigger so that you can see, because it's kind of hard to tell. But you can see this has one slope, and then when he hits his overtime pay, it gets a little bit steeper because his employer is cheap and rude and doesn't pay him a true overtime wage. All right? Let's move on. Here's a check-in. How do piecewise functions differ from linear functions? Piecewise functions can be a combination of linear and or quadratic functions that are pieced together, while the graph of a linear function is a straight line. So piecewise functions have different sections with different slopes, and a linear function is just one straight. Okay, this is an interactive question that's in the lesson. It says a dog groomer charges $35 to groom a dog if the weight is 15 pounds or under. So this right here is going to be M for our first problem, our first section, okay? If the dog's weight is over 40 pounds, over 15 pounds and and 40 pounds or under, the groomer charges $45. So that's our second M. Create a piecewise function. So the first thing we need to do is define the domain for each of these. Let's do the first one. So the domain for the first one is the smallest weight is 0 and the highest weight is 15, and x goes in the middle here. So 0 is included, so we have x is greater than or equal to 0. 15 is included, so it's x is less than or equal to 15. Okay, let's do our second one. Our lowest range is 15 pounds, and our highest range is 40. Let's put x in the middle. Now 15 is included here. It cannot be included here, so x is just greater than. Because if she's going to have a 15-pound dog, she needs to know, do I charge rate 1 or rate 2? She can't be confused. You charge rate 1. So it has to be over 15 pounds or equal to or less than 40. Okay, for rate 2. Rate 1 is $35. Okay, and rate 2 is $45. Okay, we've got those. Now we need to create a table of values. Oh, sorry, we need to create the formula. So formula for number 1 is going to be y is equal to our rate of change, m, which is 35, times x, which is whatever the weight of the dog is when it's between these two. Okay, so here's our first formula. We cannot write our second formula until we figure out some points for our first formula. So we have a table of x and y. Okay, I'm going to bring it down here. Our lowest value is 0, and our highest value is 15, and then the middle value would be 7.5. Okay, so we're going to take this formula that we just made and plug in our x values. Now here's the thing. We only need this bottom value, so I'm only going to solve for the bottom value. We have y is equal to 35 times 15. Okay, we're going to bust out our calculator for that because I'm not playing that game. 35 times 15 is 525. Okay, so this is the coordinate pair that I need. Okay, I'm going to go ahead and erase this so I have some more room to work with. Now we need to use our formula that is the y minus y1 is equal to m times x minus x1 in order to find our equation for this formula. Okay, so we're going to go y is equal to y1 is 525. Okay, equals m, our second m is 45, so 45 times x minus x1 down here is 15. All right, PEMDAS says, sorry, this is just minus, that is not equals. I do that quite often. Okay, this is 5. So y minus 525 is just going to drop down. We need to distribute this 45 out, so we end up with 45x minus, and then we need to figure out what 45 times 15 is. Calculator time. 675. Okay. We need to get rid of this 525, so we're going to add it to both sides. And that is going to give us y is equal to 45x. And then I'm getting my calculator for that. I'm not thinking that hard. That gives us 150 plus, oh no, it's minus. I apologize. Come on, eraser, minus 150. Okay, so there's our formula for number 2. Y equals 45x minus 150. Now we just need to take all of this information that we have and transfer it into our final equation. And then I'm going to go double check it because I screwed this one up already. So this will be our first formula, which is, oh sorry, we don't put the y because y and f of x are interchangeable. So this is our y is equal to 35x, then you put a comma, and then you put your range, which is 0 less than or equal to x less than or equal to 15. Okay. And then we have 15. Simply look. Oh, no, 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 no. We need our formula. Watch me, watch me. Ooh. It's 45x minus 150, comma, and then we have 15 less than x less than equal to 40. Let me go double check that and make sure I didn't screw it up. Well, guess what? I just used up all the chances on it to see if it would give me the answer, to see what the correct answer was, to see what I could do wrong. Yeah, it didn't give me the correct answer. It just said that I was out of chances. So I don't know what I did wrong. I've Googled it. I've tried to figure it all out, and I have no idea what's wrong with this. So screw you, math book. That's my solution. Select the graph of the piecewise function. And there should be like f of x is equal to blah, whatever here. Okay, so we have x minus 4 when x is less than or equal to 1, and 2x when x is greater than 3. Okay, so the first thing we need to do is look at these little things on the end. X is less than or equal to 1. Okay, so here's x is equal to 1. So it's going to be here, and it's going to be everything that way. So it could be that one. It could be that one. This one's out. It could be that one. Okay, these three could work for that. Now when x is greater than 3, okay, that could be here. Nope, because see how that's colored in? It can't be that one. So here's 3. It could be that one. And here's 3. It can't be that one. So this is your correct answer. Let me go double check that one since it thinks everything I do is stupid. It agreed that I was correct on that one. Whatever, math book. I don't care. Here's question number 1. During a 3-hour snowstorm, snow fell at a rate of ½ inch per hour for the first hour. Then it increased at a rate of 1 inch per hour for the next 2 hours. Create a piecewise function and graph that represent the scenario. Okay, this one is all you. So go do your best, come back, and we'll see if I am smart enough to do this or not. You know, maybe I'm going to have to just give up on this lesson because I am a quitter. Okay, so first we need to figure out the domains for each of these. So during a 3-hour snowstorm, snow fell at a rate of ½ inch per hour for the first hour. So this is our first m, and this is our second m. This is the rate of change, okay? So for the first hour, that range is 0 to 1, and x is right here. So when x is greater than or equal to 0 and less than or equal to 1, I'm guessing, it's going to be, m is going to be 0.5, okay? And then for the next 2 hours, so we have 1 to 3 with x in the middle. 1 got included up here, so it can't be included here. 3 is included here, and m is going to be that. Now we need to write our first formula. So we have y equals m, which is 0.5, x, and then we don't have a b, okay? We'll go ahead and make our little chart. We have x and y, and it says the beginning, which is 0, the middle, which we don't know yet, and the end, which is 1. The middle is 0.5, but the only one we really need is this end one. So let's take our formula, which is y is equal to 0.5 times x. Our end x value is 1, so our y value is 0.5. Okay, we can use these values to create our second formula, which is going to use the formula y minus y1, which is 0.5, is equal to m. Our second m is 1 times x minus x1, which is 1. So first we have to distribute all of this out, which is going to leave us with just this. Okay. So now we got to get this 0.5 over, so add 0.5 to each side plus 0.5. It's going to give us our final formula, which is y is equal to x minus 0.5. There's our second formula. All right. Okay. So now that we have both of our formulas and we have our domains, you would write your f of x is equal to, and your little bracket, okay? You'd have your formula 0.5x and your domain, which is 0 less than or equal to x, less than or equal to 4. And then down here you'd have x minus 0.5, and a comma, and then you'd have 1 less than x less than or equal to 3. Okay. Oh, this isn't 4. I'm sorry. I wrote that sloppy. This is 1. I wrote it bad up here because I can't write with a mouse. Okay. And then they want you to graph it. So I'm going to go over to GeoGebra to do that. We are at geogebra.com. Start our calculator. We're going to put y equals 0.5x. There's our first line. Click down here and go y equals, itchy nose, x minus 0.5. Okay. Now the only thing you need to remember is that because this is a piecewise function, it's not actually two separate lines. We have this line from 0 to 1 and then the blue line from 1 to 3. Okay. So this part of the line disappears and we don't have any of this nonsense over here. It goes foomp, foomp. Okay. You can see here we have all of the correct formulas, and then it didn't do the majigger, the graph. I'll go get it. Okay, here's what the graph looks like. I'll go ahead and blow it up for you so you can see a little bit better. You can see it has one slope until 1 and then a steeper slope until 3, like I just showed you on GeoGebra. And all of this is the same information we had because I did it right. I don't know why that first interactive question was wrong. We're just going to pretend that didn't happen because I don't care, because that's how I roll. And everything is disappearing on me because, you know, this thing loves me. Question number 2. A rental home costs $125 for the first 4 nights and $100 for each additional night stayed up to 10 nights. The total cost can be represented by a function. Gabriella stated that this situation could be represented by the following piecewise function. F of x is equal to 125x with a domain of x is greater than or equal to 0 and less than or equal to 4. And 100x with x is less than 4 and greater than or less than or equal to 10, sorry, whatever it says. Is she correct? Why or why not? So pause it, figure it out, come back. Okay, so sitting here and picking this apart, we can see that our first m value, I need my tools back, I need my pen. Where are you? Okay, our first m value is going to be 125, and our second m value is going to be 100. So it makes sense for this formula, but this formula you can't just write. You have to get your beginning and end points. So I'm guessing she went wrong there already. This says no, Gabriella did not use the ending point from her first function to create the second function, which is what I just said. You can't just decide that you're going to write your second function. You have to do complicated crap because math is evil. That's just how it is, okay? The piecewise function should be this, which makes more sense because here it's just 100x, but it should be 100x and something because it's not starting at the beginning. It does have a y-intercept type majigger going on, okay? Here's practice question number 1. This is at the very end of your lesson, and so you'll want to just write this answer down so that you can enter it later when you actually get to the end of your lesson. I put it in here because it just gets complicated later to feel like which part of the lesson was it doing? You just learned so much in one lesson. It's easier to answer the question for the section it's meant for rather than trying to do it later on your own. I'm sorry that all of these formulas keep being stupid and disappearing, but you know how much Canva loves me. Grace and her friends are planning a trip to the amusement park. The table includes the prices for tickets, which are dependent upon how many are purchased. Which of the following options includes the piecewise function that represents the given problem, where f of x represents the cost per ticket and x represents the number of tickets purchased? So we're trying to figure out which of these options is the correct option, okay? So first, let's look at the domains we have. Our first domain is between 0 and 5. So if we buy, they don't have 0 as any of our options, but that actually makes sense because you're not going to buy 0 tickets, you're going to buy at least 1. So we can tell right from the beginning that one of these is eliminated because we have X is between 1 and 5, X is between 1 and 5, and X is between X and 5? No, you can go away. You're not part of our run. Next, we have X is between 6 and 10, which they both have. Okay. And then we have 11 or more. Okay. So all of these so far can be right. Let's look at these values. X is greater than or equal to 1 and less than or equal to 5. X is greater than 6, so you can't buy 6 tickets. You can only buy more than 6. That doesn't make any sense. So it has to be that one. Don't make it harder than it has to be. Start with the simplest thing and do elimination. Okay? Here is practice question number 2, and the graph's gone. I hate that it makes this hard for me. Practice question number 2, which option represents the piecewise function shown in the graph? Pause the video, figure it out, come back. Oh my gosh, it has all these stupid things that are missing again. Stop it. Just, oh my God. I don't know why it does this. It only does it sometimes. I haven't figured out what causes it to do this. It's obnoxious. Anyway, there's all your formulas. Which one is the correct one? Pause it, figure it out, come back. Okay. So if we look at this, we can see our first x value is 0 and negative 2. We're dealing with x between negative 2 and 0. So let's see what we can eliminate using that information. X is between negative 2 and 0. This doesn't make any sense because there's no negative 2. And x is between negative 2 and 0. This one is x is negative 2 and everything past it. So no, that doesn't make any sense. But neither does that. Oh no, this is 0. I'm sorry. It's not negative 2. X is 0 and everything past it. I apologize. I'm looking at the wrong axis. Okay, so it could be either of these. Now, let's look at what's included and what's not. So this one does not include the 0. 0 is not included here. Okay, 0 is not included here. 0 is included here. That one has to go. There you go. We're done. Just that quick. Here's quick check question number 1, and guess what's missing? The stinking graph. Okay, create a piecewise function that represents the graph. So here's all of these, and here's the graph. We need to know which one of these matches here. And look, it deleted another formula. Canva, you're upsetting me. Okay, so how you're going to figure this out is first, look and see what your domains are. This one is running between negative 1 and negative 3, so go here. See if the first x is between negative 1 and negative 3. Okay, that one is, that one is, that one is, that one is. So that didn't eliminate anything. This one is between negative 1 and positive 1, so the next one should be negative 1, positive 1, which they all are. Then you need to figure out which one's included. If the circle is open, it does not include it, so it does not have an equal sign. So this negative 1, negative 3, the negative 1 should not have an equal sign under it. Okay, this negative 1 should not have an equal to. So that eliminates 2 of those right there. All the rest should have equal to signs. Okay, that should get you pretty dang far. If that doesn't solve it all, I'm assuming that will solve it all because it has for everything. But if it doesn't, then you're going to have to start looking at slope. Like this line has no slope, so it's just going to be x or 1x or something like that. This one does have a slope, and this slope I will help you figure out. It's rise 2, run 1, so this slope is going to be 2. I believe in you. You can do this. Quick check question number 2 with no graph. Okay, which option represents the piecewise function on the graph? So we have a graph right here. We have 2 lines because we have 2 different pieces of this piecewise function. So the first thing you're going to do is look at the domains. We have one domain running from negative 1 to negative 3, so that we should have negative 1 to negative 3. Okay, and then you have one running from negative 1 to positive 1, so you should have one that's negative 1 to positive 1, and that should eliminate everything for you. Check in. How do you identify the domain of a piecewise function? A piecewise function is composed of multiple functions, therefore the domain is a union of the functions. The domain of each individual function is found by looking at the beginning and end points of the function and identifying the corresponding values on the x-axis. Here's example number 1. The graph, which is not there, represents the taxable income in a state. What does each section represent in the context of this situation? Okay, here's the graph now. The labels for a graph show the 2 quantities that are being related. The graph represents the tax rate that a person receives, which is right here on the y-axis, and based on their taxable income amount. So this is how much they make, okay? This is the taxable amount. This is a piecewise linear function, so there are multiple sections of the graph to consider. Since the sections are straight horizontal lines, they don't have any slope to them. The tax rate is consistent for the entire section or taxable income amount. If you fall anywhere in this section, you're paying the same percentage, okay? Each section has closed and or open circles to define the start and stopping points of the taxable income amount. So if I'm right here and I come up, I'm paying this rate where it's closed, not this rate where it's open. Okay. The closed circles represent a number that is included. For example, $0 for the first section is included here. Okay. The open circles represent values that are not included, which $10,000 is included there, but it's not included in the second section. Putting this together, you will find the following. We need to get our graph again because, you know, why would it pop up? See, it's supposed to be right there, but it's not, so we have to get it back. There you go. Beautiful. Putting this together, you will find the following. The first section demonstrates that if you earned $0 to a little under $10,000, the tax rate will be 10%. Okay, here's $10,000. You're paying 10%. The second section demonstrates that if you earn about $10,000 to a little under $40,000, the tax rate will be 15%. The third section demonstrates that if you earn about $40,000 to $91,150, the tax rate will be 25%. The last section demonstrates that if you earn $91,150.01 to a little over $190,000, the tax rate will be 28%. If a person makes $42,000, okay, you would come down here and find it somewhere in here, they would fall into this third section. Therefore, their tax rate would be 25%. The reason for this is because you must consider multiple sections when figuring out how much of a person's income will be taxed at the top rate. The first 10%, everybody's paying 10%. Then for the next, you'll be paying, for the next 30,000, you'll pay 15%. Okay, it's more complicated than you need to worry about. Check in. What do open and closed circles represent on a piecewise function? Closed circles represent values that are included in the function, and open circles represent values that are not included in the function, but still represent the starting point. Here's example 2. The graph represents Jaden's trip to the library. What graph? There is no graph. She made a stop at her friend's house on the way to the library. Describe what is happening in each section of the graph and determine the total distance she traveled. See that right there? That's the graph that doesn't exist.